Alright, it's time to get started with a new section. We've built our app now to have sign in and sign up functionality. But things are starting to get a little bit complicated. You see, React is a UI library. It's focusing on the UI. As our apps get more and more complicated, our state is going to grow. It's going to get more and more complicated. And in this section, we're going to use a new library called Redux to make our React state more scalable. Now, Redux is a pretty tough topic to understand, especially if you haven't learned it before. But the key thing in this section, as we progress through the videos, which you may have to revisit a couple of times because there'll be some new terms that we haven't heard before. But the key takeaway of this section is to understand that our app, as it grows, becomes more and more hard to understand how the flow of data is. And at the end of the day, programs are a way for us to manage the flow of data. And if you remember, our key to being a good React developer is to decide the state and where it lives. And this section is all about that. We're going to be using Redux as a state management to really focus on this point so that our code becomes cleaner, our app becomes easier to debug. And you'll notice that although Redux may be confusing to understand, our app will become easier and easier to understand and how data flows because of Redux. So stick with us. I know this is going to be a tough section, but state management is a big, big topic. As a matter of fact, in this course, we're going to talk about things like Context API and GraphQL, which are different ways to manage state as well. We have lots to get through, so let's get started. Welcome back. React is simply a group of components that are rendered in a tree-like structure. So this would be the app.js. And each one of these components would have state. For example, the red dots over here, they have state. So for example, this app component will have a state of signed in as, and let's say the state is user. In that case, this user component might have a state of user Mitch. Or if signed in as is admin, it might render the admin component. And anytime you see the blue dot, that means there was a change. So if there's a change here, it can update something into this component and re-render. And we did this in React. So again, with a simple React app, we can have nice views and maybe have different states and different components. But eventually, as our app gets bigger, we end up with something like this, where we have more and more components, more and more state within that component, or we can have one massive state at the very top here, which also gets pretty hard. And all these blue dots, as they update, they also have to update the state and then re-render. And this example over here is just a little diagram, but you can see with all these arrows how confusing it's going to get, and keeping track of all this state is really, really hard. So we need some form of a state management. And Redux solved this problem for us. How can we make this diagram simpler and make things easier to understand in our heads as developers? Redux came up with a novel concept. What if we just remove all the state, so this.state, from all the components? What if we just have props? So all these components just have props being passed down. And now the state, we keep it in a store. And a store is simply just the state, which is this.state that React had, but in one massive object, just like you see here. So one single object that describes how our app should look, and all we do is just pass down that state to whichever component needs it as props. So our diagram from looking like this with just React can go to looking like this with Redux, where none of the components need to hold state anymore. And we can have one massive object that describes our entire app, and whichever component needs that prop can just be passed down to it. And any updates that happen go through the state the state gets modified, and then we pass down that information to the component. This diagram might be confusing without actually coding anything, and we'll come back to it so this makes sense. But even just visually, you can see that this diagram looks a lot simpler than the diagram before it. We have a lot less arrows and everything just flows nicer. So as we go through the videos, you're going to get more and more familiar with this idea of state management. But I want you to keep in mind that that is what Redux is solving. Redux is a library that makes state management easier, not only for React, but for any tools that we use. It just happens to work really, really well with React. And Redux actually got inspiration from database design, from things such as event sourcing or CQRS, which you can read up more on. Databases had the same problem. All these updates and all these changes happened, but we needed a way to make sure that all these changes are organized in a nice, cohesive way. All right, let's get into the next video and get a little bit deeper with Redux. Bye-bye. Why do we want to use Redux? As we mentioned before, Redux is really, really good at managing state, especially large state. So Redux is a library that we would want to use if our apps get bigger and bigger and bigger, and they have a larger and larger state. Remember, we want to use tools based on the problems that they solve. And Redux solves the problem of what happens when React apps get really, really big, and using just this.state just doesn't make sense anymore. It gets more and more complicated. Remember, React is what we call a view layer. It's really good at the view side, but not necessarily at managing state. So use Redux when things get really, really complicated. The second point is useful for sharing data between containers. And this is another thing with when projects become large. When they need to start sharing state between containers. With React, this is actually a little bit difficult, and you have to move the state up one layer so that you have a parent that can share state between the two. But with Redux, this becomes really, really easy, as we're going to demonstrate in our coding section. And finally, Redux has predictable state management using the 3 principles. Now, what are the 3 principles? These 3 principles in Redux are going to really, really make sense at the end, but I want to still introduce them to you so that we're aware of them. The first one is the idea of single source of truth. And this is a fancy way of saying that we have one single big object that describes the entire state of the app. Remember this? We had one massive state object that describes everything within our app. So we have our single source of truth. Because React reacts based on whatever the state is, we can just have one big object that describes how the app should look, and React will take care of it. The second principle is the idea that state is read-only. And this encourages something called immutability, which is not modifying the object. And it prevents unexpected errors this way. So the state object that we will create with Redux will actually never get modified. And instead, we would create a new state after each action is taken by the user. And then finally, the third principle is the idea that changes are made only using pure functions. Something that we've talked about in my previous course. The idea that a pure function is something that receives an input and always returns an output that is predictable. If we enter the same input 1,000 times, we expect that function to have the same output 1,000 times. Using these principles, Redux has some new words that we're going to introduce in our vocabulary. And we're going to be comfortable with them by the end of this section. The first one is action. An action is something that a user does, such as clicking on a button or a drop-down menu. And what happens in Redux is as soon as a user clicks on something, a button, and creates an action, it goes through something called a reducer. And a reducer is simply a function, a pure function that receives an input, which is the action, so the user just clicked on a button, and creates an output. And this output is the state, or the store, as we call it in Redux, which is the entire state of the app. So as it goes through the function, the store gets updated, and React, because it notices this state change, makes changes to the view layer. Again, these are words that we're going to encounter as we start coding along. Now, why do this? I mean, can we just have an action, and then an action happens, and then we just make changes? I mean, that's how something like jQuery used to work. And yeah, it looks more complicated, doesn't it, adding all these steps beforehand? But as you can see above, if you have tons of actions happening, which with modern apps that are very interactive, this happens a lot, where the user scroll action and then clicks a button and then highlights something and so on and so forth. You see that the more and more actions we have, the more changes we have to make. And those changes might trigger other actions, which trigger other changes and so on and so forth. And it can get pretty complicated, as you can see in this diagram. With Redux, we make sure that all the actions go through one reducer. Everything flows through this function. And through this function, it always, because it's pure, returns the same state based on the action and updates the store. And this store now, which represents what our app should look like, makes changes. So it kind of funnels all these actions into one reducer so that everything is predictable and nice. Again, one of those things that's hard to really explain without encountering the problem first, which we'll get to. Now, Redux, and I want to teach this just for historical purposes, uses an architectural pattern called flux pattern. Architecture in software is used as a way to make sure that we're able to solve problems in a logical sense and in an organized fashion. And this flux pattern, which inspired the library Redux, has this idea of having an action and then having a dispatcher that dispatches this action to the store, which is our state, which updates the view. And it's one-way data flow. Everything flows one way. If the view gets updated, we go back to the action and again goes through dispatcher that dispatches the change to the store and then to the view. And this was a pretty revolutionary idea because before that, we had something called MVC, or Model View Controller. And you may have heard of it. It was quite popular. The idea with an MVC pattern is we have an action, and that action is read by a controller. So again, another JavaScript file that looks for actions, user clicks on a button, and based on whatever the controller says, we update the model, or the data in this case. So we can think of it as state. We change something in the model, and then it updates the view. Now, the problem with the MVC pattern is, well, this diagram over here. We have the controller that changes different pieces of the model, and this model can change the view that can trigger another change, and that model can change another part of the view, and so on and so forth. And we have this thing that we saw before. We have the craziness of actions and making changes. All these arrows just crisscrossing and not looking very nice. And although it might not be bad when your apps are smaller, as your apps get bigger, you want to do something like this so it's logical and makes sense. And that's what we want to do with architecture. We want to architect our apps in ways that as they grow, although we may add a few things, in the end, everything is easier to reason about and understand. So we have the flux pattern, which enforces a unidirectional data flow. We have the MVC pattern, which could definitely be improved. If you get anything out of this video, the one thing I want you to understand is the idea that Redux, at the end of the day, is pretty much the same as this.state in React. With Redux, we can replace this.state and theoretically remove all of this.state from React and have it all happen inside of this Redux library, which again, we're going to do. But one caveat, you could technically have Redux with the state, but also still keep a little bit of React state in a component. Redux doesn't replace completely the this.state or this.setState in React. You can still use them together. But like I said before, without having gone into any of the code of Redux, this might look a little bit overwhelming and confusing. I promise you, things are going to make sense by the end. Before I throw code onto the screen, I want to make sure that you have some principles and concepts that we're working from.
We have reached a point in the application where we have to start reconsidering how we manage state. Now, in this section, I'm really excited because we're about to cover Redux. If you've looked at the React ecosystem at all, you've heard this being spoken about almost extensively and constantly because it's such a huge and integral part of not only React development's history, but also it's a humongous part of how apps are built today and how they have been built for the last 2 to 3 years. Now, before we actually start writing any Redux code, we have to understand some fundamental concepts of Redux, but also why we need a solution like Redux. So in order to understand why we need the solution, we have to understand the problems that it's aiming to solve. Now, in this lesson, I'm going to try and explain to you where the problem comes from in our existing app already. So, where it begins is let's look at our app component. So anything related to when our user that we just built and authenticated and stored in our database and then store in our state is all kept on our app state inside of our top level app component. If we wanted, for example, to pass this current user into the header component, as we already have, we just pass it to the header. But let's say inside of our header, we had a cart component, and that cart component for some reason needed the current user. So if we were to imagine that we had some cart component nested in here that needed current user as well, we would be passing current user from our header, which gets it from the app. But if our header component did not need the current user and only our cart component needed it, but our cart component was still nested inside of our header component, then we would have to drill that prop down from our app into our header before finally passing it from our header into our cart. This style of drilling props down from components into their children is a bad pattern because the props in between, those components in between, don't actually need that prop. Only the child needs that prop. And potentially the child of the child is the only one that needs that prop. So let's look at a diagram and see how this looks. Let's say we have these squares that represent components. And the further they go down is where they're nested, right? So this component is a child of this component, which is a child of this component, which is a child of this component, before finally being a child of our app component. So our app component stores the state of the current user on its local component state. If our header component had a cart component inside, as we just demonstrated, that needs the current user, well, we would be passing it from our app component to our header component before our header component finally passes it to our cart component. But what if our cart component was also being used in a different section of the application, right? And in that application, it's even deeper nested. So there's a page component, and some other component before finally reaching the cart component. We see that we would end up passing our current user down 3 to 4 components that all might not even need the current user. And in that sense, this component suddenly now has to consider that it might get current user as a prop, even if that component gets used somewhere else and cart component is not even a child of that component. We have to write our code suddenly to be flexible and have these conditional props just because there's a chance that cart component is a child of one of its children. We can see how that makes our code way less reusable. And just in order to make it reusable, we have to add these sudden conditional properties. That makes it so that this parent has to be aware of its children's component props without it really being necessary. Now, one way that you might be thinking that we could remedy this is what if we were to take this state, right? And this component did mount, all these code that gives our current user current user data to be stored on this component. And what if we moved it into cart component, right? Because cart component needs current user. So why don't we make it so that cart component's also listening for the current user, right? And then they store the state locally. And then that would avoid this problem. Well, the issue with doing it that way is now that anywhere where we have that component, that cart component, it suddenly has its own state of the current user. And that current user might be reused in app state, header, cart component, and then this cart component, right? And other components. Not only are we repeating the code, which is bad, but we're also having multiple states of the exact same current user data. And that is bad because if any of them are misaligned, if the current user data here is different from the current user data here, but then that's a problem because now they're supposed to be referencing the same object. What this is it conflicts with our concept of unidirectional data flow. Because with unidirectional data flow, we always want the state to be the single source of truth. We want one state, in fact, to be the single source of truth. That's why we were putting our current user in our app component, because we would still just pass it through, right? All of our components. So is there a way for us to still get one single source of truth of where we keep all of the data that any component needs, but then directly have our component access that data? We can do that, and that's what Redux aims to do. Redux aims to be the single source of truth of where we store data that might be used in multiple parts of the application. And then we should be able to access that data from just that component without having to go through all of this prop drilling. Now, this is how the concept of Redux works. We have these components that compose our application, and they get props. The components then fire actions. And those actions could be anything. They could be triggered from user clicks, right? They're essentially, as they sound, they're actions. These actions then update the state, the way that we do set state, right? We have actions that trigger set state inside of our components. But instead of setting local state, what if we set a single piece of state somewhere else, right? Where any component could access. Well, that is what Redux is, right? Redux has that state not in the local component, but somewhere where any component can access it. And those pieces of state are called reducers. So, for example, any state regarding users, like our current user that we're currently storing on our app, would be in a user reducer, which is just a piece of the state or a slice of the state. Anything related to our shop items, for example, that we need to display would be in a shop reducer. And then anything related to our home, if we had, like, say, our directory items, would be in a home reducer. And they all combine together into one big object, right? One big state object called the root reducer. And then from the root reducer, when the components need those pieces of state in order for them to populate and display their views, we would pass that state into those components as properties, right? As the props that they need to display in order for our components to function the exact way that we've been writing them. And this way, all of our state and all of that information is stored in one object, one place, and it still flows in one direction. And it follows, if you remember our diagram, of our unidirectional data flow. Except this is now the state, this represents our views, and these are the actions. We're still getting unidirectional data flow. And by doing this, we also avoid that issue of prop drilling. Now, this is all conceptual, but how will this actually look in the application? Well, let's tackle that. But just always, if you need to, refer back to this diagram. We definitely will be as we continue writing our application and integrating Redux. Okay, now, before we actually start writing our Redux code, it's going to be a lot of code in a style that we might be unfamiliar with. Even getting started with just writing these reducers might be a bit confusing, so I want to take this time just to show you what each piece will look like before we start writing it, so you don't feel overwhelmed with all this new code that we're suddenly writing. Now, let's re-explore our diagram and let's look at our reducers. So reducers are a fundamental part of Redux because they are essentially what our state is represented by. When I say reducer, you can pretty much picture it as an object. And the root reducer is the big object that holds all the smaller objects. So, for example, our home reducer is just an object that holds properties equal to the data that we want related to the home. Anything related to home, right, that we might want to separate in its own object will be in the home reducer. Anything related to the shop, right, maybe all the shop items are going to be in the shop reducer. Anything related to the user, such as the current user or the address or whatever we can imagine with the user, we hold in the user reducer. And they're all just objects. And they all together compose the big object that is our root reducer. And you can visualize it literally as just a big object with a property of home that goes to some object with those home data, right? Home properties. Same thing with the shop. Same thing with the user. And let's say the component wants just the user reducer. Well, we would just pass that slice, right? That object into our component as the property that that component needs. Let's say it is current user. We can just go from the root reducer, get this user object, and even just get that property of current user and pass it into our component. Now, let's say we wanted to update that user the same way that we were doing set state inside of our app.js component. Well, we do that with these things called actions. And what actions are, if we scroll down a little and look at this new diagram, is literally also just an object. It's an object that has a type on it with a string value, and then it has a payload that could be whatever we want it to be. Whatever we want to update that value to, we would just pass that as the payload. So our components will fire these actions, right, with this with a name on it, that take this shape with a type and a payload. That would then go into our reducer, which would then check the type to see whether or not that type of action is applicable to that reducer. Because if we want to update the current user, only the user reducer cares about that action. The home reducer and the shop reducer don't care about it. And the way that it works is that these reducers are going to check against the type, right? Because that string we're just going to match and say, oh, does my reducer care about this type of action? If it does, I want you to update the whatever property it is. In this case, it's the current user property with the payload on that action. So these actions update our user reducers with the payload. And then our user reducer passes that current user in as a prop to the component. And then the component will render however it needs to with the prop. And it will continue to always follow this flow. Let's say the user logs out, right? From our app component, we would then fire that action again. Set current user would be the action. So the type would be set current user. Payload would be null this time because the user logged out. So then our user reducer would update current user with null and then pass that null current user property into our component so that our component can render null as current user or do whatever it wants with it. At that point, our component cares about that property, but our Redux does not. So if we want to look at our reducer code, the way that a reducer looks is every reducer is just a function. The function takes a state and then it takes an action. The state is the previous state that it was in, is the state before this new action is going to update it. So we can even see this as previous or current state. And what we would do is with this function, it's going to return an object. It's going to return an object, and that object is going to be the new state of our user reducer. It's going to be a new object. So what we do to determine that is we use what's called a switch statement. And a switch statement is kind of like a really big if statement. So we're checking the action type, right? Which is that string value we saw here. We're going to check the type. If the case is that action type is set current user, if that's what that string of value of type is, then we're going to return a new object where we are going to just spread in current state, but make sure that the current user property is the payload. And the reason we always return a new object is because we want our components to re-render. As we remember, if we pass in the same old object, except the property is different, our components might not re-render the way we want them to because of the way that React components work. React components only re-render if their props are different. And the only way that the props are different is if the object that it has is new. If we pass the same property, i.e. the same object, but with a different value, like let's say we just passed in a modified version of current state where we instead did current state dot current user equals action dot payload. If we did, action dot payload, if we did this and this is what we return, that object is not actually different and our component will not re-update. Instead, we have to always remember to render a new object, right, as what we pass. If none of the action types match, then we just want to return current state because we don't want to re-render anything. Because this action does not affect our reducer. Our reducer does not care. The reason for this is because our reducers are listening to every action. And our reducers only change if the type is relevant to it. And we will do that with our code. So remember that. Every reducer is just a function that takes the state and then it takes an action. And then based on the action, it determines whether or not it needs to re-render. And then what it gives out is just going to be the object. And in our case, all it is just a value of current user goes to whatever that payload was. And this is going to be the type of code that we will write inside of our Redux. I just wanted to show you guys this because as we start writing it, there will be a lot of this stuff and I don't want you to be confused as we're building it. Okay, let's start integrating. In the last few lessons, we covered a lot of concepts about Redux because Redux is a very conceptual paradigm of how to build your application. And of course, we are definitely in this lesson going to set up our code to have Redux inside of it. But before I do, there's one more thing I want to cover. Now, the reason I want to cover this is because we're going to write a lot of code just to set up Redux. And it's a lot of new concepts and code that you might not understand. But if you at least understand from a high level what we're doing, you can see why we have to configure the code the way that we do. So looking back at this diagram of how our actions flow through Redux in order to trigger changes inside of our DOM, we look at this flow of events. We have some action that goes into our reducer, right, our root reducer, which then propagates changes into it, which update our store, and then our store finally results in DOM changes in the right components. Along the way of these actions occurring, before it ever even hits the root reducer, it can hit something in the middle called a middleware. And all a middleware is a piece of code that gets the action before the root reducer. What that middleware does with the actual action is entirely up to the middleware, but that's all it is. They're just something that receive these action objects before they reach the root reducer. Now, we're going to explore a lot of middlewares throughout this course, but the most important one that we're actually going to use and explore in order for us to better understand Redux is the Redux logger middleware. And all that middleware does is it logs out actions that get fired and then what the state of these reducers are before and after the action. So pretty much just a visual representation of what it is that actions do, which is very useful for us to understand Redux. So let's actually write this out in the code. So if we go back to our terminal, we need to actually install both Redux as well as the Redux bindings for React, because Redux can be used in multiple frameworks, not just React. And we also need that Redux logger middleware. So what we're going to do is we're going to say yarn add Redux space Redux logger and React Redux. So those are the three libraries that we need. So as those are being added to our application, let's go back to our application and go into our index.js file. Our index.js file is where we are actually going to put the new component that we get from React Redux that will give our application access to not only the store, but also those reducers that we're going to also write. Now, that thing that we get is going to be called the provider. And the provider is a component that we get from React Redux. This provider is a component that we want to wrap around the entire application because we want everything inside to have access to this store object that we get from Redux. So we'll actually write the store object, but first, let's just understand this provider. This provider is a component that is the parent of everything inside of our application. And as the parent, it allows us to get access to all of the things related to the store that we're going to put all of the actual code we want to store on our Redux state. So that's all this provider is. And it's a component, and it's got to be the parent of everything. So now that we have our provider, we actually need to write the store itself. Now, how we're going to do that is we are going to make a new folder inside of our source called Redux. And inside of here will be all the code related to our Redux that we're going to write. So what we want to write first is actually this root reducer. And what the root reducer is the actual base reducer object that represents all of the state of our application. So this root reducer will end up being the actual code that combines all of our other states together. Now, why do we want to do that? Well, if we wrote all of the code related to all the states in our application in one file, you can imagine that it becomes really unwieldy. So what we want to do is break the code up into its individual sections. And I'll show you how we'll do that, but just understand that all of the reducers that we're going to write is going to go into this root reducer. Now, the other thing that we're going to write is actually going to be the user reducer, because the user reducer is going to be that reducer that will store the state of our current user. Now, right now, we do store our current user inside of our app state. So we just want to move that into a reducer that is pretty much going to be the same type of object. So what we're going to do is we are going to make a new folder called user, and any Redux code related to this user is going to go into this folder. And the first thing we're going to make is that user reducer. And we're just going to say it's user.reducer.jsx, and this lets us know that this file is a reducer. Now, a reducer is actually just a function that gets two properties. It gets a state object, which represents the last state or an initial state, right? Which is just an object that represents what it is that we're trying to store. And then it receives an action. That action is just an object that has a type, which is a string value. So it's just a name that tells us what specific action this is. And when I say specific, it literally means like we are going to write a bunch of actions. We're going to name them whatever it is that we want. So we want to make sure that our reducers are aware of what specific type of action that's coming through is. And it's going to be based off this type property. The other thing it's going to have, which it might or might not, is something called a payload. Now, this payload can be anything. And the only reason that we can say it's anything is because maybe with this payload object, we want to do something with it in order to update our state. We might pass an object that we literally set as the value in our state, or we might use this value to make some transformations on our state. We don't know, but it's just a very flexible property that we get on this action object that we can or cannot use. Now, that's all actions are. They're just objects that have these two properties of type and payload. And this will make more sense once we write more of the code. But as I was mentioning before, our reducer is just going to be this function. So I want to call it user reducer because that's what it is. And it's a function that again gets the state and some action. Now, again, the state is going to be something that the Redux store is going to pass to this reducer, right, whenever an action fires. And the state will be whatever the state it is currently when that action gets fired. So because when we actually fire the state for the first time, it's going to be nothing, right? Because Redux doesn't know that we have any state when the app first initializes. So when an action gets fired, there's going to be no state. So we want to make sure to set an initial state. So what we'll do is we will write a new const called initial state. And this will just be an object that represents the initial state of this reducer. Very similar to when we instantiate state on our class components, right? We make sure to set some initial state value, which is the default values when this component mounts for the first time. And we're doing pretty much the exact same thing in our reducer. So we're actually going to take this current user value and put it into our initial state because it's going to be pretty much the exact same thing. So now that we have our initial state, we're going to make sure that inside of this function call, we're going to use that initial value as what is called a default parameter value. So this is an ES6 feature for functions where you can actually pass some default value here with this equals and then the value syntax. What this means is that if state is ever undefined, meaning that it's not set, then it will fall back and leverage this initial state value that we passed here. But remember, null is considered a value. So if this value inside when you use this default parameter is ever null, like as in state is ever null, it will still pass null in as the state value and consider it an actual valid value. And it won't fall back on this default value that we set. So this is just the thing we got to keep in mind. But now that we have our reducer function written inside of this, we have to actually think about how do we return the actual state we want based on the action. So what we're going to do here is we are going to write what's called a switch statement. And a switch statement is pretty much just this statement that looks like this based on some condition. And then inside of it, we set up case statements and a default value. So it's actually very simple. What we're going to say is that based on the action.type value, which will be a string, if the case of that action type is one that we want, right, then what we'll do is we'll render something. Otherwise, by default, we are going to just return the state. Now, the caveat here to remember is that every single reducer gets every single action that ever gets fired, even if those actions are not related to this reducer. So the reason why we want to default return the state is because if none of the action types match inside of this switch statement about the ones that we care about, then we just want to return the state. So for us, the case that we care about is set current user. Whenever set current user is the action type that gets fired, we then want to return a new object, which represents the new state that our user reducer is going to transform into. And what that value will be is everything else on the state. We always want to spread in everything on the state, right? Because we only want to modify the values that we care about. And the value that we care to set is our current user. And this is going to be the payload. And that's all it is. You remember how I said the action object is just the type and then a payload? Well, for us, we're literally setting the current user value with this payload. So this reducer, I know, might be a lot of new concepts that you're not used to. But if you just look at this statement, it's a function that gets a state object and an action. Depending on what the type of action is, this switch statement will then check if the case for this action type is equal to set current user, then I want to return this new object out of this reducer function. If none of these action types match any of the case statements that we write, then just default to return the current state of what the reducer is. So that's pretty much all our reducer code is. What we'll do is we will export this out as the default value from this user reducer. And then what we'll do is we will bring this into our root reducer because now we have our reducer, our first reducer. Now, if you remember, I mentioned that the root reducer represents the overall reducer based on all of the reducers that it pulls in. In order for us to combine them all together, we actually need to import this function called combine reducers. And this comes from the Redux library. So with this, when we import our user reducer from our new user reducer file, we are going to export out this as the default value, which gets returned from combine reducers, passing in this object where the key goes to the actual reducer that we want. So if you remember, our full state in Redux is just one big JSON object. The keys that represent the individual slices of state, i.e. the actual reducers, is the actual individual reducers that we've wrote. So this user reducer is just currently this object with a current user value that will get set whenever the set current user action fires. We are then pulling that into this combined reducers, which will return it into one giant object that is appropriately bound with all the Redux functionality that we want. So I know it seems complex. I know there's a lot of code that we wrote, but this is what we need in order to get started. So with this, we've written our first reducer, but we still have to actually bring it into our store and instantiate our store. Well, how do we do that? Well, this video is a little long, so I'm going to end it here, but in the next section, we're going to bring our new root reducer into our store, as well as create some other stuff, such as actions, so that we can actually flesh out the first Redux feature inside of our application. So I'll see you in the next lesson. We just wrote our first reducer, our user reducer, and we got introduced to some new concepts and some new JavaScript features, such as the switch statement and this default parameter value inside of our function. But now that we have our reducer and we imported it into our root reducer and used our combined reducers function from Redux to create our actual root reducer object, we need to still create our store. Now, in order to create the store, we have to make another file inside of Redux called store.js. And this one is just going to go into its own file, and I'm going to call it store.js. Inside of store.js, we need to import in the create store function, as well as the apply middleware function from Redux. So if you remember from that image that I showed you, what we need to do is add middleware to our store so that whenever actions get fired or dispatched, we can catch them and then display them. And the middlewares, which is the piece in the middle between our actions firing and our root reducer, are pretty much just functions that receive actions in and then do something with them and then pass them out into the root reducer. That's all it is. This Redux logger library that I made you guys install is pretty much just that. And all it does is it catches the action, it console logs it out for us, and then it moves it along. So all we need to do to bring that in is we just import logger from Redux logger. And this is a really handy middleware because once we finish writing all of this configuration and setup, which is quite extensive, I totally understand, it will make it much easier for us to understand what it is that we did. So once we have these required libraries, we then import in our root reducer from our root reducer file. And now we have to actually set up our middlewares. So the middlewares that the store is expecting from Redux is going to be an array. And that array, we can set ourselves as this thing called middlewares, right? We just set it as this const, and we make it an array, and inside is our logger middleware. This is pretty much just that function that I was telling you about from Redux logger, and we're putting it inside of this array. Next, in order for us to actually make our store, we're going to literally call it our store, const store equals create store. And this is a function that gets both a root reducer and also the return value of apply middlewares. And inside of this apply middleware, we are going to spread in our middlewares. So what this will do is this will spread in all of the methods or all of the values in this array into this function call as individual arguments. And this way, if we ever needed to add more things to the middleware, we can just add it to this array value that we have here. Now, you'll actually see us do this later on in the lesson, but for now, just understand that we're doing it in this syntax just because it's more scalable. And you'll totally see that as we build it out. Otherwise, we didn't actually have to set this value. We could have just put them in manually, like so. This would have perfectly worked because we only have the one logger middleware, and apply middleware just takes an infinite number of different middlewares that we can just put them in like so. But instead, we're just going to do it this way because in the future, we might want to modify this array based on certain conditions. You'll totally see it. Don't worry. But this is just one thing to keep in mind. And with this, we've written our store. We're going to export this out as the default value. And then with this new store object that we've instantiated with create store, we're going to bring this into our index.js and we're going to pass it into our provider. So I know it's been a while since we covered the provider in the last lesson, but just as a refresher, the provider is this component class that we get from React Redux that once past the store object, we'll be able to give that Redux store context to the rest of the application. So we can dispatch actions to that store, or we can actually pull values off of the store and into our components. And it all comes from this provider. So in order to do that, we need to import in the store from our store.js, which is inside of our Redux folder as the store. Now, once we have this, we are just going to pass it in as a value called store in provider, like so. And that's it. It's a lot of configuration, guys. I definitely totally understand that it's way more configuration than you guys are probably used to seeing. But with this code written like this, we now have access to Redux inside of our application. We had to build out our store. We had to configure a root reducer, so we had some kind of value for us to actually display. But now that we have this, we can actually start implementing the right actions into our application so that Redux can start storing the value of our user into our new user reducer and out of our app.js state. Now, in order for us to do that, we actually have to create the action that is going to trigger the correct case inside of our switch statement. Now, as we know, this set current user is what the action type we're expecting to be, so that it sets the current user value inside of our user reducer object as the payload of this action object. Now, what we're going to do in order to make that is we are going to create these action creator functions. And they sound way more complicated than they actually are. So what we're going to do to make them is we're going to put them inside of a file called user.actions.js. And they literally are just functions that return objects. The only thing is that each object is in the correct format that the action is expected to be. So for our set current user action creator function, it's going to be a function that takes one parameter, the user object, whatever that user object is. It's either our user auth, right, or our user snapshot object that we create inside of our Firebase utils, as you remember from our app.js, or it's null. So instead of calling this.setState, we are going to fire off an action that holds that value that we were setting state to before, and we're just going to call it our user. Then what this function returns is an object where the type is set current user. This is the exact same string that our reducer is expecting. So we just got to remember that. We got to make sure that we always align the action creator's type with the reducer's type expectation in order to create the appropriate effects in our reducer. And what we're going to do with that user is we're going to set it as the payload. So as I mentioned, this shape of an object is all a action is. It has a type, which is equal to a string, and then it has a payload. And because these strings should never change, we want to use capital and snake case. So we want to use underscores wherever there's spaces. And with this, we've created our user action. So we have the action that our components are going to leverage in order to actually update our reducers with the appropriate values. Now, I know this was a lot of configuration in these last 2 lessons. It was just us setting up so many things. And honestly, it's a lot and it's very overwhelming. Redux is definitely one of the more challenging concepts in the React ecosystem because of this reason. There's so much setup required just to get started with Redux. And in each of this setup, there's a concept we got to think about because Redux is so opinionated about how to be used. And this is the trade-off of using Redux. But I promise you, it's extremely, extremely valuable and super powerful. So in the following lessons, we're going to see how we use this, how we bring this into components, how this all looks in the end. And I know you had to endure a lot of this configuration, but hopefully, at least conceptually, it made sense about why we had to do this. But we're going to use this a lot. We're going to repeat this pattern many, many times. And once you watch those lessons, please come back to these videos, watch this again, try and do it yourself. Try and set up this Redux yourself using the Redux documentation that I'm going to link inside of your resources. And you'll hopefully understand why it's all happening. But Redux is definitely a very large picture kind of library. You have to see it all in action before all of these pieces slowly start to make sense. And once it all clicks, you're going to have that eureka moment. So with all of these concepts and all of this configuration that Andre and I have taught you guys, hopefully this makes some sense. If it doesn't, I promise you by the end, it will definitely make sense because we're going to use it a lot. So now that we've finished our setup, we're going to bring this into our component so we can start leveraging not only the new user action we created, but also this current user value inside of our reducer. And we're going to do that in the next lesson. So now we have our user reducer and our user actions. We know conceptually that we need to bring our user reducer's current user value into where we need it, which will be our header component. Because right now our header component is getting current user from app.js. And we don't want that. What we want is for our header component to pull that current user value off of our reducer. So how do we do that? Well, the first thing that we would do is we have to actually import in connect. Whoops, capitalized by accident there. We have to import this function called connect from React Redux. Connect is a higher order component that lets us modify our component to have access to things related to Redux. Now, as we remember, higher order components are just functions that take components as arguments and then return you a new souped up component. So what we'll do with connect is we are actually going to pass it two functions, the second one being optional, and then that'll give us back another higher component that we pass it our header. Now, what is it that we pass as the first argument of connect? It's going to be the function that allows us to access the state, with the state being our reducer, our root reducer to be specific. We know that with our root reducer, it is an object that has a property of user that points to our user reducer, which right now is just this initial state because we haven't triggered any actions that update the value of current user. So we know that we will end up getting current user of null, but we want that value. So how do we get it? Well, we're going to write that map state to props function, and it's going to be equal to a function. And what we're going to return from that function will be an object where the name of the property will be the actual property we want to pass in, and then the value will be the value. So what do we get in this function is the state object. This state is the root reducer. So the top level root reducer. And we want to pass in a current user property where the value of it will be state.user.current_user. So we're saying we want the root reducer, right? We want the user value, and then which will give us our user reducer. And then from there, we want the current user value. And by doing this and passing map state to props to connect, now we're getting that null value as current user being passed in as current user. So now we can remove the passing of current user from our app state into our header. And if we now go to our header component, we'll see that we're no longer signed in. In fact, now we're signed out. But that's because we're getting our current user, which is a value of null from our map state to props, which is then respectively triggering us to see our sign in link. Now, this map state to props and this connect we will use anywhere we need properties from our reducers. So this pattern we're going to write in a lot of our future components. But just remember that connect is a higher order component that gets either one of these two functions, the first one being this one, and the second one we're going to cover in the next lesson. So now that we've modified our header component to be receiving the current user value from our reducer, we now have to actually update our app component so that it's able to update the reducer value with the new set current user action that we made. So how do we do that? Well, what we're going to do is we're going to have to modify our app component with connect as well. So we're going to import connect from React Redux. And just like we did earlier with our header component, we're going to connect our app to the outcome of our initial connect call using the second argument of connect, which is map dispatch to props. Now, the first argument is map state to props, but our app doesn't actually need current user anymore, because outside of passing it into our header, it only sets it, but it doesn't do anything with the current user value in its component itself. So what we can do is pass in null as the first argument, because we don't need any state to props from our reducer. The second argument will be our map dispatch to props, which is a function that gets this dispatch property, and then similarly will return an object where the prop name will be whatever prop we want to pass in that dispatches the new action that we're trying to pass, which is set current user. So let's import in set current user, because we need that action. So we're going to import from Redux, user actions, set current user. Now, what we'll end up returning inside of our map dispatch will be set current user, but it goes to a function that gets the user object and then calls dispatch. And what dispatch is it is a way for Redux to know that whatever you're passing me, whatever object you're passing me, is going to be an action object that I'm going to pass to every reducer. So our user action is a function that gets the user but returns an action object. So we are going to call our action, but we're going to pass that user in, so that what we're doing is we're invoking set current user with the user that will then be used as the payload. But this returns the object. So we're just dispatching the object. And now we're going to pass map dispatch to props as the second argument of connect. And now we'll have this value of set current user. So we don't need this constructor anymore. And instead, what we're going to do is we are going to replace this set state code with our set current user action code. So what we'll say is we will say this.props.set current user with the value. And now we're going to still pass in that object with our snapshot whenever our snapshot comes in, but we want to set the current user value to it. Now, because we're also going to do it here, let's actually destructure this off of our props. Set current user equals this.props. And then instead of now using props, we can just call set current user and similarly do the same thing here. But we don't need to pass it an object with current user. We just need what the object we want to update it with. And now if we save, whenever our user snapshot updates, we are setting the user reducer value with our new object. And we can actually see this in our application because of our null. Wait, what is this? This.state. Oh, whoops. So our header doesn't actually need current user anymore. So we're accidentally passing that in still. So now if we look, we'll see this in our console log. So what these are actually messages that we're getting from Redux Logger, that library we included when we yarn installed React and React Redux. What the logger tells us is the state of our Redux after any action is fired. So each one is actually these three sections. The first section is the state before the action was fired. The second one is the action itself. And then the third one is the state after the action has modified any of our reducers. So if we look, the first time our reducer was in the state where our user was equal to current user of null. This was the initial state of our user reducer. This was our action where we had a payload of our, you remember, our user auth object, right? The big object that we get back from our Firebase. And then the type is set current user. And then the next state will, of course, now have our current user value be equal to that payload value. Just as we know that this is what Redux is doing, right? The reducer code. Now, if we look at this next one, This is after we get the snapshot. After the snapshot modifies our user auth object to now be our database user object. So we'll see, as before, right? Our current user is equal to that big object. And then it fires again because our on snapshot code is now firing set current user. And what we'll get is our object that we are storing in our database. Display name Mike, email Mike, right? And then here we'll see that our reducer is now up to date with our new modified database object. And if we look at our header, we actually see that it says sign out again, because now we're actually triggering our reducer to store the current user value that we are passing in with our map state to props into our header. So this is that flow we were talking about. This is how we're able to bring in all of our state props into our components, right? But now they're separated because now our header is no longer dependent on app passing it in, but our app still updates our user reducer value, so our header is able to get the latest current user property. This separation is a wonderful thing because now our components are truly components. They're isolated, individual, and only know what context they need to be aware of. Now, if we hit sign out, we will see, right, we are setting current user again, but this time with our null value because we've signed out, right? And then if we sign in with our email and password, we'll see that we fire another action again, but this time we are now with our user again. So that's the flow of Redux. Now we're going to do this pattern many times because practice makes perfect, and we're learning a lot of stuff in this lesson. But this will be incredibly useful to us in the next following sections of building our application. Now, let's just commit our code and move on. So let's go back and see what we added. So we know we added our Redux. So we'll say added Redux and implemented user reducer and user actions to header and app components. And now we'll git push, and let's keep building our application. Let's make a small modification to our app. Right now, if a user signs in, they are able to still access the sign-in page, which we don't want them to be able to do because they're still able to trigger any of the code in our sign-in, mess with the auth flow. We don't want that if they're already signed in. So how do we do that? Well, what we want to do is we want to set it so that if they have a current user inside of our application, they shouldn't be able to access the sign-in route. And in order to write that code, we're going to need two things. The first is we're going to need the redirect component from React Router DOM. And then the second thing is we're going to need the current user from our Redux state. So just like we did in our header, we're going to need a const map state to props. And off of our state, we're going to destructure off our user reducer. And what we'll return is our current user prop, which is equal to user.currentUser. And now we're able to pass our map state to props to our connect so that we have access to this.props.currentUser. Now, inside of our route, we're going to switch this first to exact. And then, instead of this sign in and sign up component property, we're going to use render. And render, you can imagine, is exactly like the render key that we use in our class components. It's a JavaScript invocation that determines what component to return in the same place where component would be. Instead, it'll be some JavaScript. So here we can say that it will be a function that will determine based off of our this.props.currentUser, right? Because if it's present, then what we want to render is our redirect component that we just imported. And all it takes is that to property that tells it where we want them to redirect to. And then if not that, we want to instead render our sign in and sign up page. And that's all there is to it. So now if we go to our app, we'll see that we no longer are able to access sign in, right? It'll redirect us. So now, not only do we want that, if we hit sign out, and let's say we go to sign in, if we sign in, it should redirect us to our home page. Okay, so now that we have our redirect set up, one more modification that we should make is to our action. So right now, we saw that we're using this string, this hard-coded string, right? And in our reducer, we're referencing the same string. But one best practice that we can implement is to make sure that it's consistent in any place that might be referencing this string. So what we'll make is a new file called user.types.js. And what we're going to export from this file will be an object called user action types. And on it will be the value that points to that exact string. And now in our reducer, we are just going to import that in. Let's just use the autocomplete, and it should be user action types. And instead of set current user, we will say user action types.set current user. So now we know that it's constant and we won't have accidental typos and not know why our code is not working. We'll do the same thing in our action. We'll import user action types from our user types.js. And we'll just use the value. And now if we look, we see our code is still working the same. Okay, so now we've done our modifications. Let's commit this code as well. So we'll check the status. And we'll say git add, git commit, updating our app to redirect to home if user is signed in. And then we'll git push. And let's keep building. Now, the next thing we're going to tackle is a pretty big feature. And the feature is our cart. So if we go to our final application, we'll see that our cart is represented as this shopping bag icon with a number inside that increases whenever you add items to it. Inside, when you click this icon, it will create this drop-down that shows you the items that you currently have in your cart. Now, we have to keep in mind how we're going to store these items, because if we go to our checkout, we also see the same items. And if we start increasing the quantity here, we actually see that our shopping icon is also increasing in that number. So this seems like it's two places in the application that uses the same state, which is perfect for what we know about Redux, because we know that these two components are going to share the same state. Now, how do we build this? Well, there's a lot going on here. So in this section, we're going to put together a lot of the concepts that we just learned and expand upon them to build this exciting feature. So let's go back to our application code. And what we first need to do is bring in the actual SVG for the shopping bag icon. Now, I've already provided it for you, so you can just add it into this folder of our assets. And inside of our assets, you are just going to drop the SVG in. So I'm just going to copy and paste it in. And then what we'll do is make the actual cart icon component that represents both the icon and the number. So in our components, let's make a cart icon component. And inside, we'll need our cart icon.component.jsx and our cart icon.styles.sass. So first, we'll import in React from React. We'll import in our style sheet. And we're also going to import in our shopping icon. So we're going to do React component as shopping icon from and then the URL of our SVG. Assets shopping bag.svg. Now, what we're going to write is a const cart icon equals a functional component that renders a div. And this div is going to have the class name of cart icon because it will hold both our shopping icon as well as our span that will represent our total number of items. Now for this span, we're just going to say item count as its class name. And for our shopping icon, we're going to give it the class name of shopping icon. And then let's export out by default our cart icon. Oh, misspelled default. Now I have provided for you the styling for this cart icon, as I usually do. And you can just paste this into your cart icon styles. But all I'm doing is I'm pretty much just setting our item count to be positioned above and absolutely in the middle of our shopping icon. So now let's bring this into our header component. Now let's import in cart icon from cart icon component, and let's just drop it at the very end of our header. Now if we save and look at our code, we see that we have our kite icon. Now right now none of the functionality is tied to it, but we have our icon component. In the next section, we are going to actually start building out the dropdown and all of the Redux that's going to be associated to setting that up. Now that we have our cart icon component, let's start building our cart dropdown. So if we look at our dropdown, we know that there is a container. There is this section with items inside that is scrollable. And there's also a go to checkout button. And it opens and is seemingly stuck to the area just underneath our cart icon. So let's start building this component. The first thing we're going to do is we are going to create a cart component here. And we'll just call it cart. And inside of it, actually, let's call it cart dropdown. It's a bit more direct about what it is. So we're going to create our cart dropdown.component.jsx as well as our cart dropdown.styles.sass. We're going to import React from React. And we're also going to import in our custom button because we know we need one at the very end. We'll import in our style sheet. And what we're going to use for our component is a regular stateless component. And inside will be a containing div with the class name of cart dropdown. And also this div that has the class name of our cart items, because this will be the thing that contains our cart items, which we'll keep empty for now. And then our custom button. And we will say, go to checkout on the inside. And here we will export default our cart dropdown. Whoops, cart dropdown. Now let's bring in our style sheet. So I have the styles here for you as well for this component. And I'm pushing the margin top of auto for our button so that it's always at the bottom. The cart items takes up 240 pixels. It aligns everything inside so that it flows vertically and it has an overflow of scroll. But we won't create cart items just yet. We have to bring our cart dropdown into our header component. And we got to import in our cart dropdown component. cart dropdown component. And we're going to place it just outside of our options div because we want it to sit just outside of that div. So now if we go back to our application, we'll see it right there. Awesome. Okay. Now what we have to do is conditionally show or hide this cart dropdown. And in order to do so, we are going to trigger something that will show or hide this component based off of some true or false value. Now we are going to create a cart reducer to do this, and we're going to set the value of some property, probably called hidden, on that reducer based on clicking this icon. Because maybe there are other ways that we want to hide this in the future. We don't know. But what we do want to do is we want to keep that in our global state in case anywhere else wants to trigger the ability to hide or show our dropdown. So let's implement that. So now that we have our cart icon component and our cart dropdown component, we have to figure out how to trigger our cart dropdown to hide and show based off clicking the cart icon. Now, you might be wondering if we could just bind that functionality into our header component, because both these components are here, and using our local component state, we could possibly add an onClick handler here that updates a state value on our header that sets it to true or false, and then based off of that true-false value, we just hide or show this cart dropdown. And that would be entirely valid if we were certain that the only way we wanted to hide or show our cart dropdown was within our header component. But because we are not sure of that, perhaps we want to show or hide our cart dropdown in another component. We want to move that functionality and that capability outside of the header component and inside of our global Redux state. Now, how do we do that? Well, first, let's create the Redux files. And they'll look very similar to our user files. So instead of user, we'll call it cart, and we'll make a cart.actions.js, a cart.reducer.js, and a cart.types.js. Now, starting with our reducer, we know that we need an initial state where the hidden value is true, because we want to hide our dropdown when they first come to our website. Then we're going to have our cart reducer equal to a function where state is equal to our initial state if no value comes in, so default value of initial state, and then our action. And using a switch statement on the action.type, we will now selectively render with a case of, let's say, toggle cart hidden. The reason why we want to use a toggle versus a set is because our cart component will either be in a true or false state. So it's either hidden or not hidden, right? And we know that we're mainly switching it back and forth between true and false. So instead of passing in a value for our action.payload, what we can actually do is we can say hidden is equal to bang state.hidden. So that exclamation mark is saying that whatever this Boolean value is, I want you to convert it to the opposite of it, right? So if it's true, I want it to be false. If it's false, I want it to be true. And then by default, we want to return just the state. Now, this, of course, is a string, but we want to make an action type for it. So let's go to our cart.actions and let's export default cart action types, where toggle cart hidden goes to the string toggle cart hidden. And now we just need to import that from our cart types, and it will be cart action types toggle cart hidden. And we'll export out our reducer as the default. So now we have our code. Oh, maybe I gotta move this down here. Sometimes our linter yells at us. Now, to make the actual... Oh, wait. I moved it. Oh, sorry. I put this in the wrong file. Cart types. My bad. Wrong file. That's definitely confusing. The file naming conventions. It's a thing that always used to throw me off when I was first learning Redux. So definitely don't feel bad, because we all make these mistakes. Now, the cart action. We actually need to make the action now. So let's import in our cart action types from cart types. And what our value will be, we will set it as export const toggle cart hidden is equal to a function. And we're not going to pass a payload because we don't need one. We're just going to set type equal to cart action types dot toggle cart hidden. Payload is actually an optional property on our action object. And inside of a reducer, we're not actually using the payload inside of this respective case, right? So there's no need for us to pass a payload. We just need to know that if it's of this type, we're just going to switch it from whatever its previous state was to its opposite state. And now, inside of cart icon, let's bind that action here. So let's import connect from React Redux. And let's bring in our action type from Redux cart actions toggle cart hidden, and we need our map dispatch to props, which gets a dispatch, and we're going to call it toggle cart hidden will just be a function that triggers the dispatch of toggle cart hidden. And now we'll pass this into our connect function, passing null as the default. So now we'll be able to access toggle cart hidden here, and we can just bind it on click, like so. And now, if we look, we'll see that we fire the action. Now, of course, our state is updating. Oh, we actually have to add our cart reducer to our root reducer. So that's a step that we always got to remember. So cart reducer from our cart reducer. So this is another common mistake that we make when we first start using Redux as well, is that we'll forget to import and add our cart to our cart reducer. So now if we look, we'll see that our cart by default is hidden true. If we click it, we'll see that now it's false. So now we just have to hide and show this drop down based off of that value. So let's go back to our header component, and we'll import in, we already have our map state to props. So what we need to destructure off of our state is also now the cart and then the hidden value. So I'm actually going to show you a more advanced way to destructure as well. So off of our state, we want the user, and off the user, we want the current user. So this is the syntax you write when you want to destructure nested values, right? So by going colon and then another destructure bracket, we're saying I want you to give me this value off of the user, which is being destructured off of the state. So similarly, we will do that off of the cart, and we want the hidden value. And then instead of this, we can now just do that. And now we'll pull the hidden value off, and we can just selectively render this based off of a ternary operator. So if it's hidden, if hidden is true, then I want to render nothing. But if it's not, then render the cart dropdown component. And now if we look, we can see that we can toggle our dropdown. Now before we add our add item feature to our cart and to our application, let's commit our code. So we know that what we are adding is our cart icon, added cart icon, and cart dropdown components to our application. Also implemented cart reducer. And then let's push and continue with our add item. So now we have to introduce our add item feature into our application. But let's take a look at it in our final application so we can understand what it needs to do, so we can figure out the right strategy to approach building it. Well, first, we know that each item has a hover effect, and when we click Add to Cart, it adds it to this cart. If the item already exists, it will increase the count on it, but if it's something new, it'll add a new item here. If we go to checkout, we notice that almost the same component is displayed using the same data, except this one can modify the quantity of those items. But first, let's just build out the basics of this feature while thinking about how we can reuse this capability, because it seems like it's a very similar add to cart feature, which pretty much does the same thing as hitting this icon. We're still adding these items to the cart and increasing the quantity. But the first thing we should tackle is just converting our collection item to have this hover effect, and then set up our Redux files for our cart to be able to store our items. So let's go back to our application and let's first modify this component. What we need to do is actually go to our custom button component, and we are going to first need to invert the colors based on a property, just like we did when we added this custom class of Google sign-in and those Google sign-in styles. So what we'll do is we'll add an inverted prop that does the exact same thing as our Google sign-in, except instead of Google sign-in, we will say if inverted is true, then add the inverted class. And then in our custom button, we will add in this inverted class. And what it'll do is the opposite of what our regular styling on our custom button is. So if it's inverted, those are the styles, right? Because when we hover, we flip the colors in our normal button. But if it's not, then we want the same color. And similarly, if we hover, then it switches to what our normal button styles are like, with a border of none. Now that we have our inverted button, we just need to import this into our component. So one more thing we want to add is just something to make sure that our text is always aligned. And if we do display flex and justify content center, anything in our button will always be centered inside of our element. Now, let's go to our collection item. And in our collection item, what we are going to add is our custom button from our component custom button. And we're just going to put it after our collection footer. And inside will be our text of add to cart. And what we will also add is that inverted key. And if we look, we should at least see the button. There it is. Now, we do need to add some styles to our custom button that are only unique to our collection item component. So what we can do is we can go into our collection item styles and we can just manually add them here. So we can say that they're on our custom button. We will first set the width to 80%. We'll also set the opacity to 0.7. We want a position of absolute because we want it always to be absolutely positioned at the bottom of our total height. And that will be a value of top 255 pixels. We'll also need to add a position relative value to our collection item. And now if we look, we'll see that our button is positioned inside of our collection item. But what else we're going to need to do is add that hover animation, because by default, our custom button should be hidden. So let's do display none, and then add our hover feature on our collection item itself. And what we'll do is we'll first make our image opacity set to 0.8, and we'll also make sure that our custom button gets an opacity value of 0.85. Also need to add our display flex so that we display it. And now if we see, we have our hovering feature on our collection item. So those are a bit of style changes just to make it so that our application now can support that add item feature that we're about to implement. So in the last lesson, we finally styled our collection item component to have our hover add to cart button. In this section, let's actually wire up the appropriate Redux actions and Redux code so that this add to cart button actually starts saving these items into our cart reducer. So the first thing we need to do in order to do this is we have to add the actual property we're trying to set inside of our reducer. So inside of our application, if we go to our cart reducer, here we want to add a new property called cart items. And very similar to when we handle local state inside of a stateful component, such as a class component, we can set it in a very similar way with an empty array as the default value. Now what we need to do is we need to actually start adding items into this array or clearing them out depending on the feature. And in this case, what we want to do is we want to add items to this cart items array. So what we're going to have to do is we are going to have to add both the new actions and the new action types so that our reducers are aware of what add item action we're trying to make. So what we'll do is we will go to our cart types here, and inside we are going to make a new add item action, and we are going to use this first inside of a reducer. So what we need to think about is how we're going to do this. Now, I know that I mentioned in our final application that when we add items, it will increase a quantity instead of displaying them in a multiplicative way. But let's just start with that because we want to work from small features into their complexity first. So all we're going to do is we are just going to add the item into the array whenever the user clicks it. If there's duplicates, that's fine. They'll just show up in the array as duplicates, and we'll handle grouping them later. So what we're going to do is we are going to add a new case right underneath our first case with toggle cart hidden called cart action types using our new add item. And what we'll say is we want to return an object with all of the state, right? As it is, we'll spread it through. But now we want our cart items array to be our old cart items, and then with the newest action that got fired, right? That is triggering our add item. We want to deposit whatever the item is in the payload of that action into this array. So we'll first spread in the existing cart items that are already on our state. And then what we're going to do is we're just going to add the action payload to the end of this array. So if you're unfamiliar with this, all we're doing is we're spreading in all of our array values, and then any additional values we add at the end will automatically appear in the very end of this array, following all of our spread values from our existing array. So if this seems kind of confusing, it's okay. Don't worry, once we write the action, it will totally make sense. So just look at this right now. What we're doing is we're getting the item payload, right? We're assuming that the item coming in will be what will be the payload value on our action. What we need to do now is we actually need to write the action. So let's actually do that. Inside of cart actions, what we want to do is we want to make a new action called add item to cart. Actually, let's just call it add item. What it will be is a function that gets the item that we want to add to that array that we just made. And what we'll return is this new action type object where the type is our cart action types.add item, which will tell our reducer, hey, I'm trying to add this item. and the payload will be equal to the item. So as you remember, actions can have a type value and a payload value. The payload value can be anything we want it to be. And in our case, we want it to be the item we're trying to add into our cart items array. So now that we have this payload, right, inside of our action definition, let's actually bring this into our component so that we can actually use it. So what we need to do is we actually need to go back to our collection item, and now we want to import in all of the Redux bindings that give us access the same way that we saw when we did our toggle button. So we need to import in connect from React Redux. And then we need to import in that new add item action that we made. So let's just bring that in. Add item from Redux cart action. So with our new add item, we know that we need to create our map dispatch to props, because we need to dispatch this new add item. And I'll show you what we're going to do with this one, because now we need to take in this new item object as well. So map dispatch to props will be this function that gets a dispatch. And what we'll say is that whenever there's add item, it will get an item in as the property, right, of this function that will represent the add item prop that gets passed in. And then we will dispatch our add item action creator, passing the item in. So all we're doing here is we are simply creating this new function that's a prop called add item that will go into our collection item as the add item function that we need to leverage. And then what we do is whenever we actually dispatch or call this function will receive the item as the property, pass it into our add item action creator, which gives us back that object where the type is equal to add item and the payload is equal to the item that got passed in. And then we will dispatch that new object into our store and it'll go through our Redux flow. So here we just need to make sure, right, because we're not actually taking any map state to props, that we pass null as the first value, and then we pass our map dispatch to props as the second value. So now we'll have access to this add item dispatch into our props, which we want to make sure that we destructure off. But now is the interesting part, because we actually need access to the item that this collection item represents now in order for us to actually dispatch it into our new add item function that we wrote. So we need to actually tweak our code a little bit. The first thing that we need to do is we need to see where we're using our collection item, which is our collection preview. Normally what we do is we just spread in all of the props, as you remember, right, from the item itself, other than the ID, because we use it as the key, that is the ID value. And then we spread everything else in as a prop, which we then destructure off of our props object and use inside of our collection item. Instead, what we want to do is we just want to pass the whole item in as item. So instead of doing it like this, we are going to say that what we want is the whole item. And then for the key, we're still going to call item.id, except now we're going to pass item as the item. So as you see, all we did was just simply pass the whole item in. Key is still item.id, still using the ID. But now in our collection item, we have access to our item object. Now we still need to use these values. So let's cut these out. And what we'll do is we will do a explicit return of our function. So before, when we had these round brackets, we're just going to use our squiggly brackets, which implies that we are rendering multiple JavaScript out of this function. We will make sure to return our component from this. But what we'll do inside of our new squiggly brackets is we will say const destructure these properties that we were destructuring before from the props, except I want you to destructure them off the item. Now, the reason we're doing this is because we want these values still, because we use them inside of our component definition, but we need access to the item itself. So this way we actually have access to the item now. So we see that we're not using the ID, so let's just remove that from here. And then on our custom button, we'll say onClick is this function that will fire calling our add item, passing the item in. I know we wrote a lot of code just now just to set up our Redux, but this is actually a very simple flow once you get used to all of the moving parts. So let's actually first see it before we review this. Now that we've written this, let's go to our application. And now we'll see that whenever we click our add item to cart, we're firing our new add item action. The payload is that item that we have. And we'll see inside of our actual cart reducer that our cart is updating. And now we're displaying these items. And while they might not be grouped together, even though they're the same item, we can see that our Redux action is working. And it's firing whenever we click. Every time we click, we're getting our add item action to dispatch. And our cart is getting updated in its cart items with the newest thing that was being added appended to the end of our cart items array. So if we just go over this one more time, what we did was we had to make sure that we added the new value, which was our cart items that we were trying to track, into our initial state of our reducer. Then we had to make a new action that was going to represent what we were trying to do to modify that new property, which is our cart items array. Next, we define the actual action itself, which is our add item, which is a function that gets the item and generates this new action with the action type of add item that we just made, passing the item in as the payload, which our reducer then has to listen for with the new case for that new action type that we just made, so that whenever the action comes in, we make sure that what we're doing is we're returning the new state of our overall cart reducer. So it has whatever existing hidden value is there, except the cart items array is a new array. We have to make sure it's a new array where we spread in the existing cart items, except we append the new item that we get as a payload in at the end of this array. Finally, we have to make sure that we update our actual collection item so that it pulls into its props using the new map dispatch to props, where we make sure that when we define the actual add item prop itself, it's a function that gets whatever we want to pass in as the payload in as the property. We then return the dispatch action on us creating our actual action using our add item action creator that we defined, as you remember, right here. So as we remember, this returns the object, which represents our new add item action type, as well as the payload, which it then finally dispatches. I know this is a lot of Redux juggling. It's like we're jumping back and forth between all these Redux files, right, just to do something like this. And this is kind of the overhead that comes with Redux. But at the same time, we've now defined this function that we can use anywhere on any component that allows us to add these items into the same array that we're using in different places in our application as well. So it's kind of the right trade-off. It increases in this complexity, but it gives us these beautiful reusable functions and reusable state that we can now leverage across the application. So now that we have our add item action that adds to this array, let's actually start grouping them so that we don't get these duplicates inside of this array. So I'll see you in the next lesson. What we're going to tackle now is grouping the cart items inside of our cart reducer. So if I add this item 4 times, what we will have is the same 4 items inside of our cart items array, which we don't want. We want to instead just add some quantity property to this object and increase or decrease it based on whether or not we add the same item or we want to remove the same item from our cart. Now, how do we tackle this? Well, we're going to write a utility function for this, and there's actually many ways to handle this, but I'm going to write the way that best obeys React's rules. The rule being that whenever we make this update, we always want to return a new array, even if the object stays the same and we're just increasing the property. Because in order for change detection to trigger, we have to remember that if the object that is being used as a property to display stays the same and simply a property changes, React will not re-render the component. So we need to make sure that every time we pass in a new object with an increase in that quantity value. So let's actually write this code. So the first thing we're going to do is we are going to know that we need to call that function that we're about to write on our reducer code. And we are going to make it inside of a new file called cart.utils.js. Inside of here, we can add any utility functions related to our cart Redux code. So what I'm going to write is first this function called add item to cart, which is going to take two arguments. The first is all the existing cart items that are in our cart items array right now. And then the second item is going to be the cart item that we want to add. Because what we're going to do is we're going to look inside of our existing cart items to see if that cart item already exists. And we are going to actually write that in this code. So we're going to set it to the value of existing cart item if cart items.find is true. And cart items.find will return you the first item found in our array based off a condition that we pass in here. And the condition is based off of this function, where we get each individual cart item and we'll check the cart item's ID if it matches the cart item we're trying to add's ID. If it matches, it will set that cart item where this condition is true to our constant. If it doesn't find anything after looping through all of it, it will be undefined. So then we're going to check, well, if existing cart item exists, then what we're going to return from our entire function is our cart items.map, because cart items.map will return us a new array. And we remember that we need to return new versions of our state so that our components know to re-render properly. And what we're going to pass is cart item, right, inside of our .map. So again, each cart item. And we will do the same thing, where if cart item.id is equal to our cart item to add.id, then we will create a new object where we have the cart item, except the quantity will be cart item.quantity plus 1. Now we don't have a quantity yet, but we're going to solve that after. So first what we'll do is if that item doesn't match, we just want to return the original cart item because there's no need to update any of the components that might be relying on our object, right? So we don't need to make any modifications. We'll just return the cart item as it is. Now, if the cart item is not found inside of our array, then we want to return a new array with all of our existing cart items that were already there. But we also want to now add in an object which is equal to our cart item to add, except we're going to give it a base quantity of 1. And this way, whenever we add our cart items in, any subsequent cart items will be able to reference that quantity value that we have added to our objects when we store them. And now we just have to import this into our reducer from cart utils, and it is called add item to cart. And now we just have to replace this code with our add item to cart, passing in our state.cart items, as well as our action payload, which is the item that we want to add. And now we actually need to make one more modification. So in our shop data code, I accidentally set it so that the IDs of the items actually repeat. So even though they're unique in their respective array, subsequent arrays reference the same ID. And based on the code we wrote, this will cause a problem because it'll say that brown brim is actually the same ID as Adidas NMD. So I provided a new file with the updated simply so that the IDs are all unique on the items themselves. So you just need to replace this array with the new array that I gave you. And now we save that, and if we check our code, we'll see that, let's say I add this brown brim hat. We look inside of our cart items, and there's our object, except with the one quantity. But if I add it 2 more times, if we look in our cart, we'll see that our object's quantity value has increased, which is exactly what we want to do. We are grouping our items together based on this quantity value. And what we're also now able to do is if we need to create some kind of remove action, we can easily do so because we have this quantity value as well. So before we go on and build the actual cart component that displays the items inside of our cart dropdown, let's commit our code. So let's just check, and we have some pretty simple stuff. So we'll just say updated shop data with new data, and then updated cart utils to group items in cart reducer. We'll push this up, and let's move on.